So let's see our entire system working. So to give you a reference of like what all everything is there. So you can see our main node here. It has a LoRa antenna also connected to it. It is connected via this Cat6 cable to one LMP. This is LMP number 14. To this Cat6 it goes to LMP number 2. This is the address of this LMP is LMP20. This is a group 2 type of LMP. By group 2 I mean there is one IR sensor and humidity sensor connected to this. This is through this Cat6. We are using I2C. And here this is group 1 type. That is only one IR sensor is present. So basically speaking, an LMP is nothing but an Arduino Nano and an CAN transceiver. And to that Arduino Nano you can connect anything. You have to just mention what it is in the group, in the code, like you have to define a specific group for that type of LMP. Like if it has 2 IR sensors, you can it is a different group type and all those sensors are like the node address, LMP address is independent of the group type. So as you can see, it can be LMPs can be as basic as one Arduino Nano connected to CAN, and you can add sensors, so it increases the functionality based on whatever required. You can even attach actuators, so that too also works. So let's see how our system works. So I have connected the mains 240 volt AC to this MCB. This MCB powers this 240 volt AC to 24 volt DC converter. This converter powers these two buck converters. This buck converter outputs 5 volts. It converts 24 volts to 5 volts, which powers our node. And this buck converter converts 24 volts to 8 volts, which powers all our LMPs. So these are the buttons which you can use to navigate through all the menus inside our node. So let's see what on it. So we are currently on the default page, that is the auto scroll menu, where you can see different LMPs sending out data. So if you want to go into the settings of the particular LMP, I just need to press enter when we are on that LMP. When I press enter, I enter manual mode. In manual mode, I can press up and down to scroll between LMPs. So this could be especially useful if you want to look at an LMP for a longer duration of time, since in auto scroll it will be coming and going. So let's go into the settings of LMP2. So you can see here an error byte. This error byte shows what all error is there currently in the LMP. So currently there is no error. We will simulate an error and I will show you. If you go press enter again, you can see at what rate we are pulling data from this LMP. To see a clear difference, like how we can set different polling rates, I will set a polling rate of around 10 for this LMP. The moment I press back, the data gets stored. Similarly for LMP 14, I will set this to 2.5 seconds. So we see a clear distinction. When I press back, this got stored. So to see how the temperature data is changing, I can just press up. If I keep my hand over LMP20, you can see currently the temperature is 24.32. I remove my hand, 1. So let's wait for 10 seconds and the temperature should drop. Yeah. So we can use this polling to reduce, since the more the polling, the more data we get. So if you don't, like the temperature is something which doesn't need to be measured again and again. So we can set this polling time, and based on that time, our temperature changes. In LMP20, you can also see current humidity. If I keep my hand on the humidity sensor, the ambient and humidity should increase. Yeah. I remove my hand. So similarly for LMP14, we can see this. Let me go to LMP14. Yeah. If I keep my hand in front of LMP14, 32. If I remove, immediately it reduces to 24 because we set the polling time to 2.5 seconds. So now let's see what error byte I was talking about. I go into LMP14. So currently there is no error. I will remove this cable. which should denote a sensor failure, and it gets updated here. The temperature has fallen to 0 because there is no data incoming right now, and there is an error. So normally Arduinos crash in this circumstances, but here we have we can also do auto revival. So the moment I connect the cable, the error goes away and the temperature data is back. I put my hand, so this is what is all about the LMP settings and all. Let's see how do we set node settings. So when I press back, I go into the auto scroll. When I press back again, from the default menu, I go into the node settings. So I can set the current timing. So I can also set similar to like the LMP error code. We also have error code for our node if there is failure in node. In system health, I can see how the different modules are working. So LoRa is working. You can also see the current time of the system. So it's 9 minutes 4 seconds, and it started with the default timing 1st Jan 2024 00 hours, and set the time according to our needs. I will show that also. So currently the SD card is showing error because SD card is disconnected. If I connect it, it will show okay, and CAN is okay, LoRa is okay. I will so to correct SD card, I need to just, so you can access SD card from here. So I reinserted the SD card. The moment I reinsert the SD card, it shows okay. Yeah. So continuing on, let's set. So currently this is the time. We'll see. So wirelessly the data is transmitted via this antenna. Here is our LoRa receiver. So this is a LoRa gateway. LoRa gateway is connected to my local Wi-Fi network, and my laptop is also connected to that network, and I could see the data coming. Let's see. So you can see here the data is coming. So we set LMP20 to send the data of group 2 to send data every 10 seconds. So you can see we got a data here at 11:07. Let it scroll. At 17 another payload of data is exported. Yeah, at 17 we received another payload. And similarly for 14.1, that is node 14 and group 1 sensor, we are getting data every 2.5 seconds. Here the setting, like here the data is coming at the accuracy of seconds, so you can't see 0.5 seconds here, but yeah, you get the point. So this is coming to us wirelessly. This constantly updates the CSV file. So the data which is coming here, we can get a live GUI also. Like in substations, you won't have a person looking at this and interpret something. So this is directly fed into a CSV file, and from that CSV file we fetch live data here. So you can see the data being fetched live here. So this is for node 14. If I keep my hand over node 14, you can see a temperature rise. Yeah, clear cut temperature. If I remove, see a temperature drop. Similarly, we can go here. We can go to node 20, and so this is 10 seconds. So it's taking a lot of time. Oh, sorry, I kept my hand in the wrong place. Yeah. So the temperature increases. I remove my hand and the temperature drops. So it also shows humidity here for node. So even this dashboard is very smart. Like it shows that humidity only for node 20. It's not for node 14. Also get an audit log. Currently I have set the alarm is when any sensor reaches 60 degrees Celsius. So there is no alarm right now. If I turn on my soldering iron, so I will go to 20. I will set the polling time a bit faster so that you can see the difference. And reduce it to 2.5 for this also. And if I keep my sensor, like if I keep soldering iron on top of this, you can see a jump. It's difficult to keep on top here, but I have managed it somehow. You can see a jump. Yeah. So it's difficult to keep it on top of the sensor. So if I don't keep it on top, the temperature drops. Yeah, but we have seen that the temperature now should rise. So just close. So I should get an alarm. So go here. You can see at what timestamp I got an alarm, from which LMP, what was the alarm type, and what was the recorded temperatures during that moment. So this could be helpful in that way also. So this is at auto reload now. If you don't want auto reload, you have a checker box here. You can just click it and you have to just press the button to reload the data. Now let's set a custom timestamp. Let's change the timing. You can see that also. So this is idiot proof. So it properly shows how much time is there. Let's say today's date is 16th of July. So 16th of July. It takes care of everything. So you need not worry about February is having less days and all, because it's already taken care of. Current time is 19:45. So unless you press back, it is not going to get saved. The moment I press back, this timestamp is saved. Change. So you can see our timings have indeed changed. One concern might be the data which it is transmitting wirelessly, isn't it prone to get hacked or something? Someone can tap in and see that. So we are using AES-128 security. Unless and until someone knows your specific key, no one can access your data. So one more feature I wanted to show was how we can open, example, sometime maybe our LoRa connection is lost and we want to see offline any data which we had collected offline. So I can just press on upload. I can get a telemetry demo. Fine. So yeah, so you can also get SD card data.